In this video, we're going to look at formulas and names of ionic compounds, but specifically ionic compounds that contain transition metals. So ionic compounds with transition metals. And what makes transition metals different than typical ionic compounds? We're still dealing with a metal atom and a non-metal atom, but when we're dealing with transition metals, we're dealing with this middle section of the periodic table, the D sublevel. And what we found about the D sublevel is, in many cases, the transition metal will have multiple charges that it can be. So for instance, everybody in column 1A always becomes a 1 plus because they're losing one valence electron. All of the elements in column 2A become a 2 plus because they're losing two electrons, two valence electrons. But we found out with the D sublevel in quantum mechanics, those energy levels of principal quantum numbers are so close together, sometimes these elements can lose a different number of electrons. For instance, Mn can lose 2 or 3 or 4 or 7 electrons to become a 2 plus, 3 plus, 4 plus, or 7 plus. So the question is, how do we determine which element or which ion it is for that specific element? So first off, when we're looking at the names of the element, names to formulas, when we're looking at the names to the formulas of elements, titanium, and then a Roman numeral 3, chloride. So if we were writing the formula for this element, titanium 3 chloride, the Roman numeral will give us the charge that is on that element. So titanium with a Roman numeral 3 indicates that this is a 3 plus charge. That's what this 3 indicates. And then chloride from column 7A is a 1 minus. So we see that the 3 plus and the 1 minus do not cancel. So we need two more 1 minuses. So the formula of titanium chloride would be TiCl3. Titanium 3 chloride would be TiCl3 because titanium with the Roman numeral 3 indicates that, yes, titanium could be a 2 plus, 3 plus, or a 4 plus, but because of Roman numeral 3, it indicates that titanium's a 3 plus, Cl's a 1 minus, so we need 3 of those. So we end up with the formula for titanium 3 chloride to be TiCl3. Another example, cobalt 2 sulfide. Cobalt 2 sulfide. Cobalt on our oxidation chart can be a 2 plus or a 3 plus. Because of the Roman numeral 2, we know that cobalt is going to be a 2 plus. That's what the Roman numeral indicates. The sulfide, it ends in IDE, so we know it came from sulfur, is in column 6A, so it's a 2 minus, an S with a 2 minus charge. We don't need to add any more pluses or minuses. The 2 plus and the 2 minus cancel, so this becomes COS. Then let's look at palladium palladium with a Roman numeral 4, palladium phosphide. The Roman numeral 4 for palladium, when we look up palladium, palladium can be a 2+ or a 4+. In this case, the Roman numeral 4 for palladium indicates that it's a 4+. Palladium 4 phosphide, a P with a 3-. P with a 3- because it's in column 5A. So we need these to match, which means I need another P with a 3- and then a PD with a 4+, another P with a 3-. That gives me 9 minuses. So another PD with a 4+, and then finally a P with a 3-. So palladium with the Roman numeral 4 indicates that it's a 4+, and then P with a 3- phosphide ending in IDE, so we know it comes from the periodic table. So we end up with 3 PDs and 4 Ps. PD3, P4. Then, for the transition metals moving from the formula to the name, let's look at a couple of examples of these. Let's say that I've got Fe2O3. Fe2O3. When I go look up Fe on the periodic table, it can be a 2+ or a 3+. I need to figure out which one it is. Well, Fe2 is Fe and Fe, 2 Fe's. 3 O's, so we go 1, 2, 3. The O's is in column 6A, so we know those are going to be 2- charges. The Fe, we don't know what they are, but we know there are 2 of them. If each of the O's is a 2-, that gives me a total of a 6-. So I've got to get to a 6-, or balance a 6- with the 2 Fe's. So each one of these would be a 3+. Does that make sense that Fe could be a 3+? Yes, that's one of our options. And so when we name this, it's going to be iron with a Roman numeral 3, because we found out that its charge is a 3+. Iron 3 oxide. Another example is Cu2O. Well, Cu, there are 2 of them, so I would put Cu and Cu. And when I go to the periodic table to look up the charge of Cu, it can be a 1+ or a 2+. So we don't know at this point what it's going to be. But when I look up O, there is only one here, and it is a 2-. It's in column 6A, so it's a 2-. Well, this has to balance the 2-, so that would be a 1+ and a 1+. When I go to the periodic table and look up Cu, 1+ is an option. Copper with a Roman numeral 1. Copper with a Roman numeral 1 oxide. Copper 1 oxide would be the name. And then finally, let's look at scandium. The Roman numeral scandium 3+, SCBr3. So if we have this formula, SCBr3, there is 1 SC, and there's 3 BRs. BR is in column 7A, so it's a 1 minus charge. That means SC has to balance those 3, so it must be a 3 plus. When I look up SC on my periodic table, it's a transition metal, but note, there's only one option for SC, and it is a 3 plus. When there is only one option for the ion, SC has only one option, Zn has only one option, Ag has only one option, Cd has only one option. When there's only one option for the ion, we do not include the Roman numeral. So this is just simply scandium bromide. The only time we include a Roman numeral is when there are multiple options for the transition metal charges. I hope this helps in understanding ionic compounds, including transition metals, going from the names to the formulas and from the formulas to the names.